Left-hand column, we have examples of quadratic functions. On the right-hand column, we have examples of quadratic equations. What do you think makes the functions a function versus the equations an equation? One side of a function is a variable. That allows us to choose any value for x, substitute it into that function, and generate a corresponding y coordinate. For example, if we were to set up a table of values, I can choose any value for x, substitute it in here, and get the corresponding y coordinate. With an equation, we can see that one side is going to be a numerical value. That indicates that we can only have specific values for x, that when we substitute those values back in, we will in fact get that number. In this particular quadratic equation, if we were to graph it, y is now equal to 0. So on our y-axis, we're going to look when y is equal to 0, what are the values of x? Those values of x are the solutions to the equation. When I substitute those back in, my right-hand side of the equation will equal 0. So when we're looking for the solutions to that quadratic equation, if it's equal to 0, we're looking for the x-intercepts on the graph. Those x-intercepts can also be referred to as the zeros or the roots. So if you're asked for the zeros, the roots, the solutions, they're all kind of interchangeable. Now, if we have a quadratic equation, we can have either two distinct real roots. So in this particular case, it's crossing that x-axis 2 times, and both of those roots are different. We can have one real root. If the vertex of that parabola lies on the x-axis, we're either opening up or we're opening down. Or we can have no real roots if it doesn't cross the x-axis at all. So the vertex is below and we are opening down, or the vertex is above the x-axis and we are opening up. There are 3 different ways in which we can solve a quadratic equation. In this lesson, we're going to look at how we can solve one by graphing, and there's 2 different methods we can use. So the first method is we're going to write the equation in standard form. So we want it to be that ax squared plus bx plus c equals 0. So I can see that in this example, my c value happens to be -10. I want to move that over so that it is equal to 0. So if I'm going to move that over, I'm going to add 10 to this side to bring that to 0. And then I need to add 10 to the other side to keep it balanced. And because I don't have a constant term on the left-hand side, I'm going to rewrite it and it's going to come out like that. We're going to grab our graphing calculator now, and we're going to enter this function into the calculator. So we're going to go into y equals, and then we're going to go negative, and then this is our variable key, x squared, and then plus 3x, and then plus 10. And then you can see that my window is just my default settings there. We're going to graph it. So this is essentially the same thing we did when we were graphing our quadratic function and looking for the x-intercepts. It's the same process because we can see now that y equals 0. We're looking at where on that y-axis are we going to have a value of 0. Those are the x-intercepts. Okay, so because I'm looking at the x-intercepts, not the vertex, I don't need to worry about adjusting the window. So same thing we did previously. We're going to go second function trace. We're going to choose number 2, and then the calculator prompts you. So it says, are we to the left? And we have to do these one at a time. So maybe let's start here. We can see this is where our cursor currently is. So we're down here. So what I'm going to do, only using the left or right arrows, so that's going to keep us on the function, I'm going to scoot over here. So imagine there is a vertical line passing through that x-intercept. We are now on the left of it, but we're close to that intercept. So we're going to press enter to say yes. Then the calculator says, are we to the right? So now, again, imagine that vertical line. If I am to the right of it, I'm going to now be above the x-axis. So my y value is going to be positive. So we're going to scoot over here, and now we're going to press enter. And then the calculator says, do you want me to guess? And you can see within that range, that's where it's going to be guessing. That is where the x-intercept is. So we're going to press enter, and it gives us our first x-intercept where x is equal to -2. We now need to do it again for the other side. So we're going to go second function trace, choose number 2, your zeros, and again the calculator prompts you. So are we to the left? Imagine there is a vertical line passing through that intercept. If I am to the left of it, I'm now going to be above the x-axis. I'm going to have a positive y coordinate. So you can hold down that right hand arrow. It's going to scoot the cursor all the way over there, and then we're going to press enter. Now it says, are we to the right of it? So again, imagine there's a vertical line. If I'm to the right, I'm going to be below the x-axis. So I'm going to scoot down until I have a negative y coordinate. I'm going to press enter. The calculator says, do you want me to guess? It's going to be guessing within there. That is where the x-intercept is. So I'm going to press enter, and our second x-intercept is going to be 5. So we have two x-intercepts in this case, -2 and +5, and you have a choice. You can either list them like this, but if you're going to list them like this, do not put brackets around. As soon as you put brackets around, that indicates that it is a coordinate point. This is not going to be an x-intercept if the y-coordinate is 5. So you can either just list them with a comma, no brackets here, or you can write them in brackets. So our y-coordinate for each of those is 0. One of the x-intercepts is at -2, the other is at +5. So this particular equation has two distinct real roots. So two roots, and they are different. And you can verify those roots. Because there are two different roots, we have to do this 2 times. So my first root is -2. I'm going to take this original equation, and every time we see an x, we're going to substitute in -2. So we're going to go ahead and do that for this one. And then in my second one, I think x is 5. So we're going to take the same equation, and every time we see an x, we're going to substitute in a 5. And then you can go ahead and work this out. So we've got -2 squared is +4. A negative times a positive is -4 minus 6 is -10. The left-hand side equals the right-hand side. So if the left-hand side equals the right-hand side, we know this is a solution to that equation. And then over here we have 5 squared is 25 times a -25 plus 15 equals -10. And again, the left side equals the right-hand side. So we can see that those are the two roots to that quadratic equation. Now, the second method to solve a quadratic equation by graphing is you can actually leave it in the form it's given. You don't have to rearrange it. Graph one hand side as y1, graph the other side as y2. So the equal sign is like a barrier. So I'm going to go into my y equals. We're going to have x squared, and then that's a minus. So make sure you press the operation key, -3x. So that's what we have in as y1. So this is our y1. And then y2, we're going to enter the right-hand side of the equation, which in this case is 4. So because there's no variable here, that's just going to give me a horizontal line that is going to cross the y-axis at 4. And again, my window is just the default window. Now, in this particular case, I want to know where are the points of intersection. So I do not want the x-intercepts now. The x-intercepts on this parabola only represent this quadratic on the left-hand side of the equal sign. I want the solutions to this entire equation. So you have to remember, if you're graphing y1 and y2, we need to see where are those two crossing. So we're going to go second function, trace, and I now want the point of intersection between those two graphs. So we're going to choose number 5, and then again, your calculator prompts you. So we're going to get close by using those left or right arrows. So there's close to that point of intersection, and your calculator says, are we on the first curve? And then I want you to watch that cursor there. So I'm going to press enter, and you can see it jump. So then it says, are you on the second curve? It already jumped. So we're going to press enter again. And then, do you want me to guess the point of intersection? We're going to press enter one more time to say yes. And we only want the x-coordinate. We know the y-coordinate is 4 because our second line there crosses the y-axis at 4. So it is only that x-coordinate that we want. And then we're going to do the same thing to the other one. So we're going to go second function trace. We're going to choose number 5 again. We're going to use the right arrow. We're going to scoot over here so that we are close to the point of intersection. Are we on the first curve? Yes. Are we on the second curve? Yes. Do you want the calculator to guess? Yes. And there is your second solution when x is equal to 4. You can either just list the solutions separated by a comma with no brackets, or you can write them as ordered pairs. If we were to turn this equation into standard form, then these would be the x-intercepts of that graph, and you can verify this. So if I take my first solution of -1, substitute it in the place of x, check all the way down, does the left side equal the right side? I'm going to take my second solution of 4, I'm going to substitute that in for the place of x, and again, work out the left side, does it equal the right-hand side? If so, we have two solutions, two different, distinct real roots to that parabola. When solving a quadratic equation by graphing, you can choose which method you want to use. If you see something like this, it might be easier just to go y1, y2, and then if we go to graph this, you can see that we're going to have two parabolas, and neither of them are ever going to cross. So in this particular case, we will have no solution. And then I'll just show you, even if we were to put this in standard form and graph this, so I'm going to distribute that 2x in to get rid of the brackets. I'm then going to move everything over to the left-hand side. I'm going to set the right-hand side equal to 0, and I'm going to graph this. We can see that the parabola is going to open up. The vertex is above the x-axis, so again, it will never cross, no solution. And if there is no solution, that means there will be no real roots to that quadratic. And finally, we're going to take a look at how we can use this newfound skill to solve some problems. So in this particular case, we have a stone. We're throwing it upwards, so it's going to go up and then it's going to come back down. Its height in meters after t seconds is represented by this function. So first thing we always do when we have a word problem is we're going to draw a sketch and we're going to label what each axis represents. So we can see that in the place of y, we have h of t, so the y-axis represents height in meters. In the place of the x, we have the t, so our x-axis represents time in seconds. Now in this particular question, we want to know when, so at what time is the stone at a height of 15 meters above the ground. So what I'm going to do is take this quadratic function, I'm going to replace h of t with the height that we are looking for, which is 15 meters. So I'm going to substitute 15 in for the height, so on my y-axis, we want to know when the height is 15 meters above ground, what time are we at? And then the easiest way to do this for me is I'm just going to graph this is y1, this is y2. And then because I know I'm going to be crossing the y-axis at 15, that's going to be that straight horizontal line, I am going to go in here and adjust the window. So I want my y maximum to be higher than 15. So let's just try 20. And then if I'm going from negative 10 to 20 on the y-axis, I'm just going to set a scale of 5. You might have to adjust the window, but in this particular case, we can see those 2 points of intersection. So we're going to go second function, trace, number 5, because I'm looking for when the left and the right side intersect. So we're going to scoot our cursor close, enter, enter, enter. And again, remember, we just want that x coordinate. So at 1 second, and then we're going to do this again. So second function, trace, number 5, I want the point of intersection. Scoot your cursor over there, and then we're going to go enter, 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 and then when x is equal to 3, that's our second solution. And then this particular question says they want us to round to the nearest tenth. So the stone is going to be 15 meters above ground at 1.0 seconds and 3.0 seconds. I'm going to put something in that 10th position. So it's going to be at 15 meters on its way up, and then it's going to be at 15 meters again on its way down. As always, it's a really good idea. Quickly verify. You don't necessarily have to write it out unless the question specifically says verify, but I would do it mentally. So take this 1, substitute it in. So we're going to have 20 minus 1 squared is 1 times 5 is 5. 20 minus 5 is 15. Left side equals the right side. Take your second solution of 3. Again, if I substitute it in 20 times 3, this term will be 60. 3 squared is 9. 9 times negative 5 is negative 45. 60 minus 45 is 15. Again, left side equals the right side.